So before I talk about our experiment that we did, I would like to acknowledge my collaborators, Simon, David, Suradip, and Ted. We had quite a lot of fun doing this experiment, so I hope you will enjoy as well. I just need to, okay. So in medicine, we produce different images to look inside of human bodies, and seismologists similarly use seismic waves to look into the earth. As most of people feel these earthquakes, they sort of have an idea of what the earthquakes and propagation of the waves is doing. But what is less known is the technique which is called controlled source seismic that is done offshore aboard vessel, where we basically produce our tiny earthquakes to look at higher resolution of the upper parts of the earth, crust and upper mantle. So the idea of this experiment is to bring this lesser known technique to the classroom primarily, using a model in a lab. So here this is a sketch of one type of controlled source seismics that we will try to reproduce in the lab. It's actually wide angle refraction seismic, where we use ocean bottom seismometers as receivers, and then we use air guns as sources, which I will explain in the next slides. So this is the record of deployment of an ocean bottom instrument that we use here in France. This is the deployment by free fall. So what we do during the experiment, we deploy these instruments on the seafloor. We produce the source or the signal that you will see in the next slide. And then when the survey is done, we go and recover these instruments. We send a signal for the release. The instruments get back on the sea surface, and we catch them with this sophisticated fishing of the instrument technique and get them back on the deck. In addition to the instruments, we also produce this signal using air guns, and so I will show you now how that looks like. So this is the ship. Here we have the array of air guns that are nothing but actually cylinders that are filled up with compressed air. So you can see several arrays of these air guns or cylinders. And so when we send the signal, the cylinder is opened and the compressed air is released into the water, producing the signal. And so I think in this moment, yes, we will see actually how this signal is produced. This is from a cruise that we did in 2015 in the Atlantic. So together with Simon, the engineer who was working here at IPGP at that time, I was participating in a cruise in the Atlantic in 2022, and we were discussing how the technique that we use to look into the Earth structure or characteristics is not very well known, and we should do something about that. And we were thinking about producing this model. And about that time, EGU announced this call for EGU public engagement grants for 2022. And so we thought that it would be ideal moment for us to apply with our idea of producing or building this model. So we got the grant. And this is basically, this schematic is our conceptual model of how our experiment should look like. So we should have some sort of receiver, and we should have some sort of source, which in this case was a balloon that we will explode in the water. So that was basically the general idea for our experiment. And so from this conceptual model, we came to this. So this is what we built during this project. I have to say that it was much better, that actually it turned out much better than what we presented in the proposal. So I will guide you through the elements of this experiment that we did. So we built, we needed actually a big water tank. This is a water tank of 300 liters and a sturdy table that can hold this weight. We then had, at the same time, Lego released their first floating boat, expedition boat. So we got it, and the kids love it, but it looks like grown-ups like that as well. So we had our colleagues helping us to assemble this ship, and it was very fun, and we are very thankful. So we didn't have to spend hours building the ship. It was really actually fun and quick. The other element of this experiment is the receiver. This is a very simple, I don't know even how to call it. Let's say it's a receiver that is waterproof, so we can put it in the water and connect it to the computer, to the laptop, to display the signal. For the signal display, we use different softwares. This example is from Audacity software. It's very simple. It's not seismology professional software. It's just for displaying the signal. And sometimes we use MATLAB as well, that has good capacity of showing this signal. It works actually quite well with our setting. The other thing that we also included in the model is the model of the OBSs. These are 3D printed three models of OBSs that are developed here at IPGP. In fact, the engineers Simon, David, and Ted were the engineers who conceived and built this OBS QB model. So it was really nice to actually use this model for our outreach experiment as well. And if you look at closely, we had even the sphere inside, and it was basically a plastic Christmas ball that we Christmas tree ball that we put inside to mimic the sphere that we have in reality. The big improvement that we had from the conceptual model was this system that Simon built. It's actually remote system for remote recovery of the instruments, and I will show you that in a minute during the video. Last component of this experiment is the source. So it's a balloon, and this is the video that we made back in 2016. So this idea, I had it for a long time in my head. And so this was the first time that I tried to do something for an open house event here at IPGP. We were actually trying to just show how the signal is produced. So we had this balloon that is fixed by a rock, and we had on one side of the tank, we had an iPad in a zip lock bag attached, so it can actually record the motion. So from this very simple idea in 2016 and the conceptual model, we came to the simulation of the experiment. So our simulation starts with the PIs bringing the ship and deploying it in the water tank, and then we have the OBS team deploying the instruments. In fact, our experiment is done normally with not more than 12 participants, and each participant has their role. So we have some of them leading the experiment as PIs, some participants are building the OBS team, the instrument team, some of them are the source team. And so the source team, their task is to blow up a balloon and then explode it in the water tanks, which is now Simon is going to do. And then we have the imaging team that is actually observing the signal. So it's everybody is actually involved. And so you can see that there is some sort of signal. Of course, it's not really the real signal that we can analyze, but it's just to show the model, the concept. And now we use this thing that Simon developed to actually recover the instruments. And with that, we finish our mission of data collection. The last thing that we do, we provide to PIs this remotely operated submarine, so they can check that everything is correct on the seafloor. And one thing that I didn't mention and we didn't actually film is that sometimes there is this whale here, and I have it actually here with me. Sometimes we put it in the water during the source part when they were exploding, the exploding balloons, and to actually show that we do care about mammals. So when there is animals around the ship, we stop our activity. So we conducted, so we conducted this experiment at the different events. Last year we conducted it, or actually it was 2 years ago at open house event at IPGP. So we had about 40 primary school students who came to visit. Before every session, we do very quick quiz, 5 questions that is age adapted. And so they do it before this kind of atelier. We have a very short introduction about the main concepts in geosciences, marine geosciences, comparing Earth to different kind of food and objects that are very familiar to them. So it's example here. At IPGP at this time, we also had engineers present, so they were showing part of their work, and it was really nice because the kids had a really broader view of what they can do in marine sciences. The experiment was also conducted during Earth Day at the University of Vienna. So we were comparing the Earth with the Mozartkugeln. And I had also 2 master students who were helping me to present the experiment in German, Xenia and David. So that was also very helpful. And the last time that I presented, it was last year at Exploradom. It's a museum that is actually built to involve kids. So there are quite a lot of different experiments, building a tornado, clouds, or different kind of stuff. And then we had the opportunity to also present our model at the museum, and it was really fun. So to have some sort of evaluation of our effort, we build this quizzes, and I mentioned that they do it before, but I didn't mention that they do the same set of quizzes after the session. So there are all sorts of questions that we put. For example, whether we know better the Earth or the surface of the Earth or Mars. And then we explain that we don't know much about the topography or bathymetry of the seafloor. And we show these tracks of the ships where we actually have the information, and for many places we don't. We also show some examples where we actually have really good images and videos, in fact, of the seafloor. This is an example from Rainbow Massif, where we also explain the temperature of at the bottom of the ocean. So this is the example of what we present in the introduction, and some of this is actually contained in the quizzes they do before and after. This graph is very complicated, but the main point here is that once when we analyze the quizzes, we realize that the improvement in what the correct answers that we obtain is about 50% or more. We had this kind of low point, but in fact, when we went back and checked, this was the group that was the best prepared group that came and really answered most of the questions of the quiz correctly in the beginning. So the blue color is the correct answers after the first round of quizzes. The green is the improvement, so additional correct answers after they pass through the whole workshop session. This is the statistics of each question, just to show that not all questions are the same difficulty, and not all groups are actually having the same issues, if we can call them like that. So, for example, these two groups, basically on the horizontal axis, you have questions, question 1, 2, 3, and 4, and 5. And this is the example of the quiz for the age 13 to 15 years. And we can see that the first group had quite a bit of trouble about defining the type of tectonic plates and oceanic plate. For the age less than 9 to 12 years, they seem to be confused with what geology is. So that's the example of the quiz that we conducted here in France, but we also conducted the same quiz for the same range of age in Vienna, and it looks like for them it was more troublesome to think about whether there is life at the bottom of the ocean and whether we know more about the surface of Mars or Earth. And then the last one that we did was with the high school students that we invited here at IPGP. We worked actually with the professors quite closely. So their professors identified this question about how we define the depth of the reflector, for example, through two-way travel time. So they were really worried that the concept of two-way travel time was very difficult for them. And in fact, almost all of them after the session responded to this question correctly, but they didn't know much about concept of P and S waves. So this actually shows us that we need to work more closely with the professors and understand what is in the curriculum of physics to actually pay more attention during our presentation and during the workshop. If you want to have more details about the quizzes and all the stories that we had during conducting this work, you can scan the QR code or go to EGU. We just published a paper on this. And the next steps that are expecting us are to film the experiment for YouTube. And then we are also now having all sorts of ideas to expand this model to show other marine techniques. And with that, I would like to thank you and take questions.